process. In this presentation, we will be considering the modeling, analysis, and design of passengers bus stop successfully, just like this. Okay, so stay throughout the lesson for a better understanding, because we will be using some technical commands to be able to achieve what you are seeing right away. And just pause and give the lesson a thumbs up, like the lesson, and subscribe to this channel in order for you to be alert each time we upload a useful lesson like this on this channel. Let us start. I will proceed to the file menu right there, and then I will have to create a new project. Yes option. In the new project dialog, I will replace this with -1. Then I will scroll down to the code of practice. I'll be using UK Euro codes. Getting the template option selected and click on OK options. Here we have an Euro code template loaded successfully. We want to start the modeling of the grid lines, the grid line set out. So I'll go to the modeling tab and I'll select orthogonal axis generator. I'll pick this point. In the axis generator dialog, I will come straight away to where I have axis spacing, these provisions. Mind you, axis spacing direction 1 is the horizontal grid lines. And so for my horizontal grid lines, I will be having at first 600, then I will have comma, then I will key in 2500, and this is going to be multiplied by 2. Okay, so I will add this asterisk 2, and then comma again. I will also have 600 like this. Okay, while in the direction 2 axis is basically the vertical grid lines. All right, so for my vertical grid lines, I will be having 2500 as well, asterisk 2, just like this, and click on OK options. Now the 2500 is the spacing, okay, between the stanchions. So I have 2500 in the horizontal directions times 2, meaning the full length of the bus stop is 5 meters. The length of the bus stop is 5 meters. Okay, so I will click on the OK options to have my grid lines just like this. So this is what I actually expected. So after which you just have to proceed to the structural tree panel. Come to stories, click right here, right click, and then we will be inserting stories right away. In the add story dialog, key in 2 from the keyboard as your number of story. Click on OK options and then yes option. You go back to the stories again, select that, right click, and then edit stories. And so story 1, I will be having 600 as my story 1. You just have to follow me carefully. And then story 2, I will be having 3 meters. Okay, over to my foundations. My foundation depth, I will get it to be 900, just like this. All right, I click on the OK options to have this. I will navigate to story 1 by double clicking on story 1 right there. You can see. Then I go straight away to my reinforced concrete columns. Click right there. So we are now to start modeling of the reinforced concrete column that will connect to the foundations of this passengers bus stop. So for my sections of the columns, I will be having it to be 300 by 300 column sections successfully, just like this. Okay, so after which I will come straight away, add my hand over this provision, click and hold, then I will drag over the intersections where I want to place the columns successfully. I release my hand to have the column placed just like this automatically. Alright, after which we have to click on the close to close this columns property dialog. Then I have successfully inserted my columns. Alright, so I will now navigate to the 3D. So this is what I have at first. These columns connect to the foundations. Okay, if I should double click on the story one, you can see this is the 600 from where the grid line are now upward to the top of the column is the 600. Then where the grid line are now downward to where you have the support is the foundations depth, which is the 900. All right, so the total of the length of this column now is 900 plus 600, which is 1500. Okay, so after which I'll be placing my stanchion right away. So I have to navigate to the story 2. So I'll double click right there on the story 2 to have this, just like this. Okay, so I'll be doing this in the 3D mode, just like this. I'll go straight away to modeling tab, go to steel members right there and select steel column, just like this. I'll come to the steel section manager. In the manager dialog, I will select UC universal columns and I'll go straight away to 150 by 150 by 23 millimeter column steel column sections. I'll select right there. I'll have to rotate it using these provisions. I click it once to turn it this way, after which I click OK. Then I will start to place this column successfully on this, just like this. You can see. Alright, after which I close this dialog. So this is what we have in now. The next thing we're going to do, the cantilever beams, the cantilever steel beams. Okay, for us to get that done, navigate to the modeling tab, go to steel members and then select beam. So after once I've done that, come to the section manager, select UB, which is the universal beam. I'll be using the smallest sections, which is 12776 13 millimeter thick steel beam sections. I will select that right away, after which I will click on the OK options. And so I will have to select this point as my first point. The cantilever is going to extend 2500 up to this extent. Okay, so I have to have a sheet for the passengers that may be resting under this bus stop. Okay, so I'll click there to place the beam. So I will need to change the inclination. So I'll come to 3D right there. For me to change the inclination, I will use these options. So I will be taking it 1 meter like this. If I click here now, you will see some changes. I will have to update right there to have it just like this, but not in this direction. So I will change the directions. This direction will be 0, and then these other directions I will make it 1000, and then I'll click on update. So you have something of this kind. All right, so this seems to be nice. If I want to lift it more higher again, I can just make it 1200 millimeters, just like this. Update. Okay, so I should go by this. All right, so after which I will just have to close this dialog. After closing the dialog, I will select this beam, click on its property again. Then I'll pick this point and this point to be able to place the cantilever beam as it connects to this middle stanchion successfully, just like this. Okay, so I am done with this side. To get it to the other side, we'll be using mirror. So in this lesson, one of the things you will learn is how to use mirroring in Protastructure. So the first, I've selected the last cantilever steel beam. I will hold the control key on the keyboard so I can be able to select the other two, just like this. After which I will right click in the drop down menu. You can see mirror here. I'll pick that. Then I will just have to select this grid line 2. This grid line 2, just select it right there. Then you will have a mirror characters dialog, just like this. What you just need to do is just to click on the OK options to have it mirrors just like this. Okay, so after which we will be placing we are going to be placing the trusses, the curved trusses. So pay a very good attention to this now. Okay, so go back to the steel members, click on truss. Then pick the first point of the thrust and the second point of the thrust, just like this, and it will take us to the thrust generator dialog, just like this. We'll be considering this type of thrust, this one, and then we'll choose the first one, which is this. Okay, now the whole thing boils down to we have all settings. Okay, so the first settings you have to be very observing. The first setting is thrust shape. Okay, so click in these provisions and then you'll be able to have a thrust shape to be curved, just like this. All right, now the radius of curve is what we are going to change again. We will be having a radius of curve of 10,000, like this. All right, we will reduce that. For the apex height, we are going to change it to 600 for the apex height. So you will be having something of that kind. 600, change this to 5,000. Okay, so I think this radius is okay, but if you want to have a very pronounced radius, you can still change this from 5,000 to 2,000, just like this. So this is how you see it is invalid. 2,000 is invalid, so let's check 4,000. All right, so this is 4,000. 4,000 is valid. All right, okay, so let's go by this radius, after which you come down and we are going to be having also a cantilever. So the left vertical offsets, we need to have that provisions to be 1,200, just like this. The right vertical offset will also be having 1,200. Okay, then for the cantilever, we will take our cantilever to be 600. Okay, just like this. For the left and right cantilever to be 600. So you have something of this kind. All right, so after getting this set successfully, we go straight away to the member tab. So for the top chord, select right there and then navigate to this CHF sections. Select the diameter to be 42.4, like this. Select it right there and then you click on the OK for the top chord. Then for the bottom chord, you are going to be considering the same sections for the bottom chord, just like this. Okay, then for the diagonal, we'll be considering the same member but different section, this time around at 3.7 for the diagonal, and OK section. Okay, so you come down, we have the vertical right there. Use the same member and then 33.7 by 2.6 section. Is this a circular section? All right, so we have selected the section successfully, just like this. You go back to the general to be able to check through all your settings, so you can take note of the settings. It's just like this. All right, after which click on the OK to have your thrust placed just like this successfully. You can see. All right, so you just continue to place it just like this. All right, so after you must have done this successfully, what we need to do again is to place the pole lines. But before we place the pole lines, we'll be inserting the slabs, okay, and the beams, as in the ROC, the reinforced concrete beams, and the slabs. So for us to do that, we'll navigate the grid lines to the story one. Double click right there to have the grid line as story one. Click on the beams member right there. In the dialog, we'll be having a beam of sections 300 by 450, or we can just have 300 by let's say 450, just like this. Okay, all right, I'll pick the first point and the second point to have the beam placed just like this. Okay, after which I will close this sections. For the I will close this dialog. Then for the slab, we are going to navigate to the modeling tab, select the reinforced concrete slab right there, and then in the reinforced concrete slab dialog, here we have to give it a thickness. We will be considering thickness 150, or we will get thickness to be 200 millimeter, just like this. Okay, and then after which we want to be inserting it, but we will be choosing the insertion method through this provision where we have beam regions. So select right there the beam regions, and then we use pick point or pick axis insertions method. So select that to make it active. At this time, we are going to be picking some axis, so you have to be observing. So I'll pick axis 2 first. So any axis you pick, it is going to be showing in the insertion provisions here. So I'll pick axis 2 right away. I will go straight away and pick E again. Sorry, I will go straight away and pick E. So I will select that. Okay, that is E. After which I will select axis 3. Okay, then I'll select A, and then I'll select 2, which is the final axis, to insert the reinforced concrete slab successfully. I'll click there. So here is the reinforced concrete slab. We have not loaded this slab, so we'll go to load provisions. For the depth load, we have 2. All right, for the impose load, just click and right click in that provisions of the impose load. In the drop down menu, if you come down, you see 2.5 for parking, for parking cars and light vehicles. So we select that. Okay, click on the update to update this particular slab. Okay, so once it's been updated, we'll be placing another slab in this other phase. Okay, so we use the same procedure. I'll select grid line A at first. All right, so go back to the general tab so you can actually see clear these instructions first. So you click on these provisions to clear these grid lines labeling successfully. Then you start the new instructions. Now click here to have A. Okay, grid line A 1. All right, and then E, and then grid line 2. You come back to A again to get that instructed, just like this. So this is how to use peak axis reinforced concrete slab instructions in Protastructure. Okay, so I believe that you must have been learning a new things in this lesson. Just pause and give the lesson a thumbs up. And as well, if you are yet to subscribe to this channel, kindly subscribe so you get notified if time I upload a video on this channel. So let's proceed. So we have placed the reinforced concrete slab successfully, just like this. Okay, so we will now proceed. Click on the close options to close the dialog, after which this time around we'll be looking at the polines. Okay, so for the polines instructions, you will have to go straight away to the steel members and then you select polines. Okay, once you select polines, you just have to select the first truss and then select the last truss to have the polines generated, just like this. Okay, so you have your polines just like this. Okay, so now these polines I will be having a cantilever, okay, left and right. So I will be providing a cantilever of 600 left cantilever length to be 600 like this. Okay, so for the right cantilever length, it's the same thing. It's going to be 600, just like this. After which I will go straight away to the sag rods. There are some of the sag rods I really want to have for this. Okay, so I will remove those ones that I don't think is important. All right, so I'm okay with this, just like this. Okay, after which we just click on the OK options to have the polines, okay, generated just like this. You can see. So after I must have generated the polines just like this, I will be adding the clouding. Okay, I'll be adding the clouding this time around. So you go to the steel members and then you pick clouding. This one, picked it, and then select the polines to have the clouding generated just like this. At default, I will leave it by clicking on the OK options just like this. Okay, so you have something of this kind. The next thing, we will be having another steel beams that is going to connect in order to brace these stanchions successfully. So we go straight away back to steel member tab, select the steel beams. All right, so in the dialog, select the just have to select the section manager, go to UB universal beam. We'll be using the smallest sections for that purpose. Select it right there and then you click on the OK options just like this. All right, after which come to the 3D and then you can see where we have the inclinations. You have to make it 0. Okay, if you did not make it 0, you have it inclined again, so we wouldn't want that. We want it to be on a straight line, so we pick this point and then go straight away and pick that point. Okay, so they say the current story must be set active. Okay, so click on the yes options and then the yes options. Okay, all right, so we place that successfully, after which you deselect that. Zoom closely, this is what you have. Okay, so we are going to be bracing these columns as well. So bracing the columns, you can decide to use get to brace it. You can also decide to use angle iron to brace these columns successfully. I'll close this dialog by clicking on the close options right there. Okay, then I'll go back to the modeling type again, straight away to the steel members. I will be using GAT. Okay, this one's to brace these columns. Okay, select this and then pick that point to have this GAT just like this. Come to the sag rod. We wouldn't like to use any sag rod in this case. Okay, for the geometric, you come over to where you have the spacing to be 1000. You can change that spacing to be 300. Okay, so just you'll be having something of this kind. Let's just make it 500. So we have something like this. Okay, so after which click on the OK options. All right, so you will have something of this kind. Okay, but if you really want to use GAT, because this is also used to brace the column, if you really want to use GAT to brace the column, you can still use the angle iron. Okay, angle iron by clicking on this brace right there. So you pick the first two columns, this one and this one, and then you will have something of this kind. So in these provisions, you can decide to choose a brace type. If you want it to be V, if you want it to be K, if you want it to be X. Okay, so you can choose that successfully. You can also navigate to the profile and change the profile. This is universal angle. Okay, universal angle. If you select it, it's 90 by 90 by 8. So you can navigate the sections and then select the one that is right for you successfully. Click on the OK, and then once you click on OK, it's going to be placed just like this. All right, so we having these two at a time is a waste of material. It's either you have this one, which is the brace, or you use the get. Okay, anyone that suits you is okay. So I will be deleting the angle iron right away. Just want to show you how to do that. Okay, so if you want to also provide maybe something like a kind of a ceiling here, all right, you can also use get. You can also use polines to provide that. So come to these three sections and then select polines right there. All right, once you select the poline, pick the first beam, pick the second beam, and then you have something of this kind. Okay, so you can now change the spacing of the polines. You can decide to make it 500 just like this, and then you check it the way it is. You see it has the polines has a cantilever, so we can choose the cantilever to be 0 and then 0 cantilever just like this. You can see. All right, so after which click on the OK options to get it inserted just like this. You can see. You go back to the steel members, pick the polines again, and then you can be able to place it here this time around. OK options to have this. All right, so we are almost done with the modeling successfully. After we must have done this, what you just need to do is to go and set the loading combinations, and then you set the soil bearing capacity for your foundation design, after which you carry out the foundation design successfully. So we'll go straight away. At first, save the project. Okay, after you got the project saved, you have to just pause now. If you are yet to like the lesson, please give the lesson a thumbs up, and as well, if you are yet to subscribe to the channel, kindly do well to subscribe to the channel. As you subscribe, you are encouraging us to bring you more advanced lessons of this kind. Let's proceed. So I will navigate to the loading tab and then click on the load cases and combinations. Then I will come to loading generator and then click on the OK to load the default loadings combinations just like this for the date and the live load successfully. Click on the OK options, and then I will navigate to the slab analysis tab, and then I'll select on video analysis. I'll come to project parameters. I will go straight away to the foundations. For the soil allowable stress, we will be considering 140 kilonewton per square meters, just like this. Okay, for the title of the project, you can navigate through there and give your project a title. Okay, click on the OK options to have that done. So after which we will have to edit materials. Okay, so you click on the material editing. Okay, for at the default materials, you'll be seeing column strength concrete for concrete strength. We have to change that to a mix ratio of 25/20/25 like that. Apply it to all. Click on the OK options. Okay, so for the stick grade, okay, of the reinforced concrete, we'll be considering 460. This one. Okay, you click on apply it and then OK right there. Okay, so you have columns right there in the project, so we cannot choose the bars that we can use for column. We may not be able to use T12, okay, sections, which is the diameter 12. We won't use that, but we can use 16s. We can use 20. You can just remove this 32. You can also remove 25, or you leave it. The system will select it depending on what the column is carrying to the foundation. So click on the OK options. The same thing applicable to beam. So the concrete beam we pick right there, and then we can use 8 for beam. We cannot also use 10. We can use 12. We can use 16. You just have to remove this 32. All right. Click on the OK options. I think these are the two reinforced concrete member we have. Okay, we also have the reinforced concrete slab right there. So you change the slab. We can use 10. We can use 12 for slab. We can as well use 16. But 25 and 32 diameter will be too much. Okay, so we click on the OK options to have that defined successfully. Okay, After which come to the foundations. Okay, for the foundations, we are still using the same steel material. Okay, but come to the rebars. Then we can use 10, we can use 12, 13 is not always in the market. Okay, so we can use 16, remove this 32, and then can leave 20, 16, and 12. Okay, the program will select either one that is suitable for the analysis, okay, and design. Click on okay. All right, okay, again. Okay, at this point in time, we are going to the project analysis tab. Okay, the analysis tab. At this tab now, we are going to be checking the project if there is any error. Okay, so click on the project model check. All right, click on start check. Let's see if we have any error. You can see building model check completed. Number of error is 0. Okay, so we didn't have any error while modeling this project successfully. So click on the close options right there. So after we must have checked the project successfully, we will go straight away to the analysis. Click on the analysis. We want to analyze all the columns as well as the beams and then the steel members. All right, there's one thing we did not do, so you have to cancel this. Go back to the pre-analysis, click on this material editing. I want to show you something. Okay, so over here you have steel columns, you have steel beams, you have truss members. Okay, so these are the strengths. Okay, so you can see the smallest strength is being selected. So after analysis, the program will be able to select a suitable strength for the steel member successfully. Okay, so we have various strength for the steel members. If I click on this 2x275, you can see various strength here. The smallest strength is 235. Okay, so just click on the okay options, and then okay, that's what I want to let us aware of. Okay, all right, so we go over to the analysis tab. This time around, click on the building analysis. You have to check this and this. Okay, the program is going to analyze this. Okay, so you click on the analysis straight away to carry out the building analysis successfully and as well as design. You know, when this provision is being checked like this, okay, you are telling the program to analyze and design the structural members. But if you did not check these provisions, you left these provisions, you did not check it just like this, and you click on analysis, you are telling the program to only analyze the structure. The program shouldn't design it for you. That means you are going to design it using bash mode. Okay, maybe subsequently you will get to know about bash mode design. So I have to check so that the program will analyze and at the same time design the reinforced concrete members as well as the steel members for us successfully. Okay, so after which you click on the building analysis. So you can see a building analysis is completed successfully. The relative story drafts satisfy the limit. You can see. All right, so after which you just have to click on the OK options. All right, so you can see build analysis. You have this provision check. Good, you can see. All right, so the program will transfer us automatically to post processing. All right, the analytical model. So you can see here is the analytical model. All right, so click on close to close this particular folder dialog. Okay, so this is the analytical model. You can see. So you can activate your displacement. You activate your displacement. This is what you have. Okay, this is your displacement. Okay, being activated. You can activate your diagram, and then you have all of this. Okay, you can also check your bending moment, and then the shuffle, remove the level so that it will not be busy. So this is the analytical model. All right, so you can also activate your shear force. All right, you can see shear force diagram. You can come to contour. All right, activate a contour as well, and then you will be having something of this kind successfully. All right, so this is the analytical model. At this time, I want you to pause and give the lesson a thumbs up, and as well, don't forget to subscribe and like this lesson successfully, so our friends can also get these lessons and then learn as we continue to share our knowledge together. You can come to solid model, and then under solid model you will be having the model in a solid form just like this. Okay, so you can check the bending moment, okay, in the solid form. All right, in the local and as well as in the global axis, so you'll be having something of this kind. All right, so here is slab, so you can see everything being defined here successfully. Come over to the story to have this time around. We will be considering the foundation design. So you have to navigate to story 0. At the 3D, I will be carrying out the foundations design at 3D. So I'll get all the columns here selected just like this. Okay, right click on it, and then you have to just insert a part footings, just like this. Click on insert part footings, so it's going to boot up and then analyze and design the part footing successfully for us. So you can see the part footings. The one at the extreme end is 1 meter by 1 meter, 1 meter by 1 meter. Then the one at the center is the one we have 1.1 by 1.1 sections of the part footing. So you can see that the equilibrium is at the center of the columns. That is why you are having this. Okay, so click on the OK options to get the part footing inserted successfully. So you have something like this. So we have completed the analysis, we have completed the design successfully. If you want to check the statute of the members, if they have passed or they have failed, you can right click and then come straight away to where you have still sections designed. So you check all of this, you see everything has passed successfully. Okay, the U ratio is 70.0 something, simply means you can still reduce these sections and then it will still pass the analysis and design successfully. You can also check your trusses, and then you click there, you can see the trusses has passed successfully as well. Everything, top cut, bottom cut, the diagonal as well as the vertical, everything, none is failing, as you can see. So you can print this report attached to your file, and then you'll be able to have a documentations of your project in terms of the calculation sheet. Okay, so here we have completed the modeling, analysis, and as well as design of this passengers bus stop successfully. Okay, so in the next lesson we look at how we can take it to Protastructure and see how we can carry out these three connections design successfully. All right, so stay tuned, don't forget to like and subscribe, give lesson a thumbs up, please. All right, so I will see you in the next lesson. I still remain soft reason. Okay, see you in the next lesson, and bye for now.